Hi, Algebra 1. In Lesson 8, we're going to be looking more at correlation coefficients and how we can use them to describe our data. Here we go. We're going to start with activity 8.2, and you have a lot of data here about Priya. She's measuring or making note of the distance she drives and how long it takes to get there. We're going to put this data into Desmos to figure out how to get the correlation coefficient. So open up Desmos, make a table, and enter this data. You may want to use split screen while you do this, but whatever you do, start again when you're ready. Here I have the data from the problem. You can see the scatter plot right beside it here. And when we type in this, again, you've seen this before, y1 with the squiggly mx1 plus b. Remember, y1 and x1 are matching your data up above. And when I turn that on, that's going to have my line of best fit. But most importantly, here now we have our correlation coefficient. We're going to be looking at just the value for r. You will see an r squared there. We're not using that in Algebra 1. So we're just looking at r. You can always round this to 2 decimal points. So this would be r equals 0.99, which is telling me that this model, the line of best fit, is a really good fit for our data. It means that our points are almost in a straight line and they're really close to the line of best fit. In your book, when you're looking at the questions for this problem, let's skip numbers 1 and 2. Number 3 is what we just did. We created the scatter plot and added the line of best fit. Now I want you to answer numbers 4, 5, and 6. Number 4 is asking about the slope and y-intercept and what they mean. Remember, it gives you the slope and the y-intercept when you find that line of best fit. The x-axis is measuring distance, the y-axis is measuring time. So the slope of 0.93 means that for every extra mile, she's going to be adding on 0.93 minutes, so a little less than a minute for every mile. The y-intercept of 4.14 right here just means that if she goes 0 miles, it's going to take her 4 minutes to do that, which sounds weird, but you think about the time it takes you to get in the car, get everything situated, get going, that's about your 4 minutes. And again, in number 5, we see the correlation coefficient, 0.99. What does that tell you about the strength of the linear relationship? It means that this is a really strong linear relationship, that it almost makes a perfectly straight line with your data. For number 6, now we're going to be using the model that we created to make a prediction. So I start out with this y equals mx plus b. I can find the slope and the y-intercept from the information from Desmos. And we want to know, how long do you think it would take Priya to make a trip of 90 miles if the relationship continues? Remember, the x-axis was measuring distance, so I'm going to put in my 90 miles for x. And then the y value is telling me how long that's going to take. So using my equation here, I can figure out the value for y. I ended up getting y equals 87.85, and that's going to be minutes. Now, do you think the prediction you made will be close to the actual value? And I think that yes, this prediction is going to be really close to the actual value, and that's because that correlation coefficient was 0.99, which means that the model is a really good fit for our data and that our data points are going to be close to that line. So that's telling me that that is going to be really close to my line of best fit. As we move into 8.3 here, we're going to need to be taking some notes. We just saw an example with Priya of a really strong linear relationship, and those are words that we can use to describe these things. So the first thing we can do is describe a positive relationship, and those are going to be the relationships that have a positive line of best fit. And we can describe negative relationships, and those are going to be the ones that have a negative line of best fit. Then we can also describe whether the relationship is strong or weak. So for example, these first few are very strong, positive relationships. This one right here would be more of a weak, positive relationship. Over here, these two would be strong, negative relationships. This one is an example of a weak, negative relationship. And then this one in the middle, when our R value is 0, even really close to 0, we just say that there is no correlation here. So if I saw a relationship that looks like this one right here, I would say that this is a strong positive relationship or correlation. This one over here would be a strong negative relationship or a strong negative correlation. So in these next problems in your book, they're going to give you different scenarios, and you're going to decide first, is it a strong or weak relationship, and is it a positive or negative relationship? And then lastly, there is a possibility that there could be no correlation at all. So for example, in number 1, the number of steps taken per day and the number of kilometers walked per day, it makes sense that if you walk more steps, you're going to walk more distance. And so that R value is 0.92, and that is telling us that that is a strong positive relationship. It's strong because the number is close to 1, and it's positive because it has a positive sign on that R value. It had a positive slope when you graph it. Skip down to number 3, the car weight and the distance traveled using a full tank of gas. This has a negative relationship, you can see right there. And that 0.86, that's a pretty strong negative relationship because it's pretty close to 1. And if you think about it, it makes sense. If your car is heavy, then the distance you can go on a full tank of gas is going to be less. And so you would have a line like this with some points pretty close to the line. Number 4, the average fat intake per citizen of a country and the average cancer rate. This has a strong positive relationship, which it does make sense intuitively. If we eat more fat, the chances of having cancer are probably higher. Number 5, this is a weak positive relationship, and this is saying that the score in a science exam and the number of words written on the essay question, it's going to be positively correlated, but just because you write more words doesn't necessarily mean your score is going to be higher. Maybe you didn't write the right words to get a higher score. Number 6, the average time spent listening to music per day and the average time spent watching TV per day. It has a very weak negative relationship. And this just means that maybe if you're spending more time listening to music, you just have less time to watch TV. But it's a very weak relationship, which means that the data is going to be very scattered. If you graph this out, it's going to be a line kind of like this with data all over.